This man needs some more information. He has nothing.
Nothing else.
Just spray that.
What? No. I just put it there.
Why?
Where's my
Huh?
This man needs some life lessons. I'll do it. Hey, no, let's keep going.
Yeah, and the fact that, okay, I didn't mean actually.
It's not gonna help.
Here, who's gonna get stuck in your zipper?
Oh, James, I think it's a handout. I think you finished it.
I'll put both of them on top of each other. Put one on top of the other, not both on top of the other.
Knocking on the door yet. Yes, you. And work for 1-4. I don't think I have here 1-4. Yeah.
When we turn it yesterday.
Yeah.
That should have been on top of the.
Remember, I got it out and had to fix some.
Oh, no, that should be the right?
Huh?
It should be under the other one. So,
Yeah, it's not in here. So I'm taking your stuff in. I get you. You got some weird shit. Sorry, fine, baby. I'm not trying to say anything.
Could we all get the same one?
Yeah. And then I got some of the more of the wedding theme here. Diamond.
Oh, I like it then.
Kisses. Diamond rings.
Wait, what is this?
I myself identify as a diamond.
Find it?
maybe 1.5
No,
might be stupid.
you did. He turned it in 1.5. That's not what I got. Get back to you just now. Is it? Yeah, you'll have it, right? Yeah. Back to you. This is what we're going to do. Let's talk about characteristics. Oh, is she there? Hello, Candace.
Hello.
Okay, I'm going to this way. Okay, a little bit. We're going to talk about characteristics of things. So, as an analogy, think about kinds of information that corporations, companies, people, governments, whatever, try to get about people. Like, what are some things that you have to fill out about yourself when you're filling out a form? Birthday. Everybody has birthdays. What else?
Your name.
Name.
Height.
Maybe your height.
Sometimes your city, zip code.
Like where you live, your address. Yeah. Your weight.
Maybe your social security number.
Social security number.
Your driver's license number.
Yeah.
Driver's license number. Your driver's license, you need your eye color, right?
Hair color.
Height and weight, yeah.
Hair color, ethnicity.
What are the kind of things they ask on those personality profile things?
Favorite
Questions about you.
food, favorite color.
That kind of thing. Yeah, so you can kind of get an overall idea of a person, maybe somewhat, by getting those kind of things: their height, their weight, their eye color, hair color. A lot of times they ask for national origin, And then when you like go to a gym, they go and take measurements, right? And what do they call it? Body mass thing.
Oh, the body mass.
Index.
Yeah.
Okay, BMI. Yeah. And so there's all these different characteristics that we associate with people. All right. So what about functions? What are some things that you can have, some things you can look at to get to know a function a little bit better? And you know you got your equation. Your what?
Their roots.
Their roots. Okay, what do you mean by roots?
Where they cross the x-axis.
Where they cross the x-axis, right? Okay, so that's a good characteristic of a function. Write some of these down. Functions. And she can't see it on here, so I'll put it on the whiteboard. Let's see here. So I will share the screen, I think. So there we go. Whiteboard. That means I need to turn that on. And erase. What are some other things we look at when we're talking about functions that can help describe the function? You might think of any more? Let's see, share. And finding up. We wrote, oh, that's the wrong one. Hang on. That's not it either. Okay, let me go back to. There, the whiteboard. I'm trying to maximize it. Okay. She's waving. Quit waving. Okay. Let me minimize her. Okay, so. Yeah. Okay, so we could look at their zeros or roots, which is where they cross the x-axis, right? Another way you could call it the x-intercepts. All those are, and sometimes they call them the solutions to the equation. So what else besides, do you want to know about a function besides where it crosses the x-axis? Some of them don't even do that. Parabolas might not even cross the x-axis. You can look for intervals of where it's doing what? What do functions tend to do at different spots? Yeah, intervals of increasing or decreasing. Intervals of, and if it's a line, you could look at a slope, right? If it's steep or not so steep. Okay, and if it's increasing or decreasing, it might be increasing the whole time, or maybe decreasing the whole time, but if it doesn't, if it like increases in a part and then decreases, what else are you gonna have?
Oh, maximum.
Yeah, maximum and minimum.
Mm-hmm.
So we say maxima and minima for plural. How about something else that's kind of related to the x-intercept? Y-intercept? Is that what you said?
Mm-hmm.
I guess I could get my math off. Y-intercept, usually if there's more than one y-intercept, you don't have a function. So you only have one y-intercept if you have one at all. There are some like square root functions that don't even have y-intercepts. So turn to section 1.5. We're going to look at some of these ideas. Maybe we'll add some more to this list. We're looking at the graphs. We're trying to, this is how we can get to know functions. The first thing they have on 1.5 is domain and range. Let me add that down here. Because sometimes the domain and the range, that means how big of a graph you need to have to show the whole thing. You need to have the entire y axis and the entire y-axis and the entire x-axis, or can you just have a section of it, to be able to show the whole graph? And so that's where you get into your domain and range. And so look at the graph they have in the margin on page 49. Anybody on page 49? Where you can actually see it. There you go. Okay. They're in the margin figure 1.34. So that one, it doesn't continue to the right and to the left forever. It starts where x is equal to what? When x is -1, that's that first place on the left there. And then it kind of goes to the right up, and then the right down, and then the right up again, and then it stops where x is, where it's almost 5. But it doesn't actually ever hit 5.0. It hits 4.9999999999999, really close to 5, but it never actually gets to 5. Well, how do you know that? The open circle, right? And so the domain is that range on the x-axis from -1 up to 5. If that's all the x-axis I have, I'd be able to graph it, right? I'd be able to graph the whole thing. And so you would list it as, how did they do the interval? Okay, so they're using interval notation. I'm going to go back over here, and I'm going to save that, but I'm going to clear that. Okay. Interval notation. I'm not sure if you've ever talked about the difference between, actually, undo that. Interval notation and set notation. You know what those are? Okay. So if we have the x-axis here, and we're going from -1 to 5, all the way in that area. So that's what that's doing. As far as the x is concerned, okay? So you can indicate that using set notation by saying, here's my curly bracket, meaning I have a set, and I would say -1 less than or equal to x, less than or not equal to, just less than 5, and then another curly bracket. Okay, so this is set notation, and it gives you the interval. Y'all are familiar with that kind of notation? Okay, and then on interval notation, what they do is they just use brackets or parentheses. And so I'm going to show you, you would have a bracket and a 1, and then a comma, and then a 5, and then a parentheses, which is kind of disturbing to me. I don't like having one bracket or one parenthesis. Let me get that little thing. There we go. And it also kind of looks like an ordered pair. You got a parentheses, a number, comma, number, and a parentheses. That's like an ordered pair. But this is not. This is saying it's going from 1 to 5. And because it's a closed-in circle, you do a bracket. Okay, so that means from 1, and then the parentheses means not including, up to but not including 5. That makes sense. And so I think of it because it looks like part of a circle. The parentheses looks like part of a circle, so it goes along with that. And the bracket is just solid. Okay, so that's interval notation. And you have to kind of know, the context to know whether it's an ordered pair or not. Because if I had 2 open circles, it would look just like an ordered pair. But it would be a notation for an interval, not a point. Okay. And now let's look at the range. Let's just look at it in the book. So we're looking at how high and how low it goes to find the range, right? And you don't necessarily look at the original point, because that original point at -1, 1, see it? That's not as high or as low as it goes, right? How high does it go? So y equals what? 3. And it doesn't go anywhere higher than 3, right? And how low does it go? Like -3. So the range then in interval notation, this was the domain, and then the range. And interval notation is it actually has filled in circles there. So y equals -3 to y equals y equals 3. And we use another bracket because we're including both of those numbers. You could also say -3 less than or equal to y less than or equal to 3 in the brackets. And that would be the set notation. Good? Okay, so knowing the domain helps a lot with functions. So look at the graph on the corner, the bottom corner of the page. And let's get your whiteboard out. Go to the whiteboard. And your marker, if you need a marker, let me know. I'm amazed that the contents of your desk have stayed pretty constant.
No, so he was writing those stuff like very simple.
Okay, so on your whiteboard, write the domain and the range for that function in that corner. Here, it looks like an upside down parabola, bottom corner, page 49. Yeah, bottom right corner, yeah, page 49. Everybody write the domain and the range on your board. We use the interval notation with your either parentheses or brackets. Kind of like this or this. And if you notice, the one we did together as a class, the lines stop at those points. But on this one, the lines go through some points and then kind of end without anything. And so you're supposed to just imagine that that line just keeps going in that direction. Okay. We normally put little arrow tips on it. And so think of it as doing this kind of thing. And that's kind of more, hang on a minute, let me undo. And then over here, kind of doing that, a little arrow tip. Okay, to help you, that's going to affect the domain range. You got set notation, this is interval notation, that's interval notation, okay. I don't see anybody with completely correct answers. Actually, it's pretty, no, not really. Okay, so this is going out like this, and as it goes out, it's still spreading out. And not only is it going down, but it's going to the right, and it's going down and to the left, and it keeps going to the right, and it keeps going to the left. And so actually, I think James got this one, the domain is all real numbers. Okay, yep. Okay. And you could indicate, since that's going out forever that way and out forever that way, the domain, in set notation, they put a parentheses and they put negative infinity, comma, positive infinity, parentheses. And they act like it's an open circle because you can never get all the way to infinity. It's not really a number. So this is set notation for all real numbers. negative infinity to positive infinity. Okay, now the range, there is a point that it doesn't get any higher than, right? It never gets any higher than 3, but it does go down forever. Okay, so we would say that for the range, let me see. Easier to write cursive on this thing. We would put negative infinity, comma 3. We have a parentheses here and then a bracket here. Can we all get that? The bracket. Okay. For the range. Okay, race. And then flip over to page 50. This is where they officially talk about what we've been talking about for days already, the vertical line test. And so a lot of times we'll do that just to see if the graph is a function or not, right? And so look at A. Is A a function? No, because you see where the red line is hitting it twice. How about B? Yeah, as far as we know from that drawing. About C? What does that mean? That didn't draw the dotted line. I mean, they could draw it where it went somewhere, where it went through the first section or the second section. Yeah, it says down the bottom, note that when a vertical line does not intersect the graph, it simply means that the function is undefined to that particular value of x. But anywhere else where it would go through, it would only hit once, right? So it's a function, but it has a gap in it. That's what we call a discontinuity. Discontinuity sounds better than gap. And it takes longer to write. I prefer gap personally. Okay, so look at the checkpoint one in the corner, bottom corner of 50. I don't know if you really need to get your marker out for this. Do you think that the graph in the bottom corner of 50 is a function or not a function? Put your thumb up if it is, put your thumb down if it's not. See, all thumbs up. You're right, function. Y'all are really good at that. And then we talk about on page 51 what Jesse said. The first thing is zeros. We always want to know, where does it cross the x-axis? Because where it crosses the x-axis, let me see if I can go back to that I saved. I don't know exactly how. Show in folder. Oh, there's the folder. Aha. Is this the saved one? Hang on, it's supposed to come up. Maybe not. Not this one. That was the one I just did. Okay. I'll figure out how to get those up later. So I'm going to clear that. And let's go back to zeros. Why are they called zeros? Why are the x-intercepts called zeros? Yeah? Yeah. Because what? You're asking me? Why is it zero? I know, I'm giving you a hard time. Why is that zero? That's right. Yes. I think it's kind of funny. Why? Why? Yeah, because the y value is 0. And the y value is called the function value, okay? The function value. You know, the x is the input, and then you get a function value for an output. That's the y. And that's where all the function values are 0, the y values. Okay, and it's also called roots, like I mentioned earlier. I'm not sure exactly the origin of that. It's not like a square root, unless you're actually grafting a square root. I don't know. Then they also call it a solution. Okay, and they say to find the zeros, y'all know how to do that, right? You set the whole equation equal to 0. We were doing that earlier. And then you would find your zeros. They have some examples. Let's go ahead and go to the whiteboard and try the checkpoints, just to get some practice there. Okay, I'm going to clear this. You can use the lit up side if you want. Okay, you ready? Okay, what you write. This is the checkpoint on page 51. F of x equals 2x squared plus 13x minus 24 plus 13x minus 24. So find the zeros for that function algebraically. Then when you think you've got it, go to your graphing calculator and plug it in and see if it looks like you got it. And I don't know the answers. They don't give me the answers to these checkpoints. Can you factor? What did you just take? You multiply them, but that's not what you don't do that here. You kind of do it on your own.
13.
You say, okay, that's 48, 48, and then you kind of figure out what adds up to give you 13, multiplied and adds up. And then you get numbers here, and that's where you do this other weird stuff, okay? I'm gonna have to get her in to show us what you're talking about. Okay, what are some factors of 48? 12 and 4? 16 and 3. 16 and 3. But you want negative 48, right?
Positive 16.
Positive 16, negative 3. That's when you divide by 2.
No, you have positive. No, it's not. I wrote it down. That's why it's confusing.
That wasn't factoring.
I was like, why is this not working?
Yeah, I'm gonna do it. I'm gonna split the middle term and see if I get the same thing y'all do. 3x. 16.
X
Minus 3, there we go.
Yeah, it has to multiply to the constant term and add it to the single variable.
X plus a, and then negative 3, x minus 8, plus 8, yeah. So 2x minus 3 and x plus 8. Okay, so solve for x, what do you get? 3 halves and negative 8. Okay, now go graph it on your calculator, see,
Wait,
8. Yeah. Okay, so, yeah.
why? Wait, where?
You have to divide the 6
The
by
way
2.
that they.
Why?
Because if you
Why?
multiply the last number by 2, you
I think what you do, you multiply those, you get the negative 48, and you get the positive 13, and you come up with your numbers that multiply to give it, but add to give this. And then you put those numbers in here, but then whatever you multiply this by, you divide these by. Well, if you had a 3,
Yeah, right. I'm gonna left-handed
Two.
stuff. Just go black right there.
Oh, yeah.
and then you bring this to up front. and-
Oh.
The way I do it is I split this up into 13 becomes negative 16
That's not cool.
x plus 3x. Because that would give you 13x. No.
Yep.
Positive.
What the heck?
Negative.
It's easier to write backwards than
You want positive. So 16 minus 3.
Because naturally,
And then you can,
start from the middle and go outward when you write.
then you
So you start
factor.
from the middle and go outward to non-dominant.
You factor the 2x out of these two, and you get x plus 8.
No,
And
it
you factor the
isn't.
negative 3 out here.
No, it
you get x plus
isn't.
8. Then you factor the x plus 8 out. And you get 2x. Okay, did it work? Okay, so did y'all graph it? Who else graphed it? James is graphing.
I grabbed it, but it looked weird to me.
Oh, shoot.
What does it look
Do
like?
you have -8 on your screen?
I don't know.
She got 2 X's there too.
Let's say got -3 halves and +8.
What?
What
You
happened?
put it in a negative 24?
That's what.
Let's see, did I give you the right problem? 2x plus 13 minus 24. I got, yeah, 3 halves and -8. Maybe you graphed it properly? Oh, it's plus 13. You have a
Oh.
Okay, plus, graph. There we go, now it looks like a -8, positive 3 halves. You get it? Yeah. It's a parabola, but we don't go down far enough to see it, but yeah, it's probably right here.
Let's play.
I'll go first.
What is that from?
It's a TikTok.
Right.
Oh, the Chinese spyware app.
That's why I deleted it. You never had it first. I'm just too paranoid for it. I'll go first. Why?
Okay, Ray, so I'm gonna give you another one.
Yay. Nine.
Back to the board.
Here, right now.
Oh. I was just like, you've been quoting it for the last week.
Okay, write this down. G of t as opposed to f of x
Woo.
equals the square root of t minus 25. You're gonna set that equal to 0.
I can do
T equals square root of 25.
Of t minus 25. So I'm gonna put it up here.
This is correct. I feel like it was too easy.
Too easy. So we'll put 0 there. And then what'd you do to get rid of that radical?
You square it.
That's 25. So you squared both sides, and you got 0 equals t minus 25. And then you added 25 to both sides, and you got t equals 25. Well, graph it and see. Graph it on your calculator, see if it works.
I can't see anything.
You may need to expand your x-axis to make a x max of at least, let's say, 30. Huh?
Ah, yes, I can see it. I can see the very
You
edge.
ought to see something.
Just the very edge.
You went to the home screen.
Oh.
Where? At the very edge.
You can also try going to your data table and see what it says when x is equal to 25. It should say 0.
No, it's 0. Yeah.
You can adjust the window that you'll graph there.
It's just
When I do either one.
Well, the first pages were like different pages.
Now you gotta figure out where that is. Y'all get it? Okay, one more. Y'all gonna love this one.
Oh, my table just sits there.
Yeah, because it doesn't, it has a really restricted domain.
Not a big one.
Okay, h of x.
I do. Yay.
H of x equals, and I just pushed a button again. Equals x squared minus 2. That's the numerator, x squared minus 2. The denominator is x minus 1. Now, you want me to tell you a trick to this? If the denominator was 0, you'd get undefined, right? And so you really don't care about the denominator. In order to find out when you have 0 for y, all you got to do is set the numerator equal to 0 and solve. Just set the numerator equal to 0 and ignore the denominator. You're just trying to find where it crosses the x-axis, or where a 0 in the numerator, because a 0 in the numerator would make the whole thing 0, right?
Because to get the solution, you're setting h of x equal to 0. So when you multiply x minus 1 on both sides, 0 times anything is still 0, right? See what I'm saying?
Kind of a shortcut, but you got plus or minus square root of 2, because you always have to take plus or minus when you take the square root of both sides. That means you've got 2 x-intercepts, that's the square root of 2 and the negative square root of 2. So graph it and see what happens. Y'all just, mine doesn't want to graph it. Okay, put the whole numerator in parentheses, and then divide, and then put the whole denominator in parentheses. So you just put the numerator equal to 0. I mean, technically, what you can do is multiply both sides by x minus 1, and that would cancel that out, and that would still be 0 over here. So you still get this. But if the numerator is 0, no matter what the denominator is, you're going to have this all 0. So always just focus on that. Oh, cool.
What was that big?
1.4. Did you get a weird, twisted hyperbola?
She got
What
like
is
some
going
whack
on?
looking thing. Looks like back here.
That's weird. Give it a smaller x, like from negative 10 to 10.
Oh, that was one.
If you hit on, it'll pause it, but
Just when I saw it. I'm in danger. Hello?
yeah.
Oh, that's
So that worked. Okay, y'all sit down, have a seat.
Oh, okay.
sort of.
Yeah, but you can see where it crosses though. And then turn to page 52. We're still talking about things you can learn about a function, get to know a function. You really like to get to know them. So, on 52, it talks about finding out the intervals, where they're increasing and decreasing. Miley brought that one up earlier. And they show a picture worth 1,000 words on page 52. Up there, they show you what increasing means, and decreasing and constant, or neither, right here. The increasing, decreasing, constant, it means what you thought it meant, right? And again, it's intervals. Like look at example 4. What can you say about that function? Can you put your marker up? What can you say about A here? As far as increasing, decreasing, where is it doing what? It's constantly good. And I don't know if they say technically, mathematically, constantly.
Yeah.
But it is increasing everywhere. Not necessarily at a constant rate, but it is increasing everywhere. Okay. Even look at the origin. Do you think it's increasing at the origin? Maybe it went constant for a little bit. It'd be hard to know exactly unless you really zoomed in. In the solution, they say it's increasing over the entire real line. And you can also tell because the function is x cubed. And there aren't any numbers that have the same cube. Like if you get close to 0, you don't have like 0.5 and 0.7. When you cube them, they don't both equal the same y value. See what I'm saying? You don't have two numbers that equal the same y value. Two numbers cubed. And so you know it's always increasing. Okay, and then on the next one, B, it's increasing from where to where? How would you say that? Negative infinity to x equals. Okay, look at it there because you only are interested in the x values. Just looking at dividing the x axis up into sections. And the first section is from negative infinity up to -1. It's like if you could, let me show you. I'll draw it how they have it here. This is page 52, example 4B. And it goes up and it comes down through the origin and it goes back up. Okay, and there's 2 and that's negative. Oh, no, it's negative. Okay. That was 1, I think, right here. Yeah. And this is -1. Okay, so what's happening here is we're going to change colors. What color should I use? I haven't used green. I've used blue. Okay, so right here it is where it's decreasing from infinity, negative infinity on the left, negative infinity to the left. It just keeps increasing until it gets to x equals 1. So it's like if I was to divide, can't do straight lines. Oh, that's horrible. Okay, let me see if I can do that, fix that a little bit. Okay. So all of this over here is one section, and it's increasing in this entire section from negative infinity, all the way up to -1, and then we'll bracket that, I guess. Okay, and then you got it decreasing from -1 over here to +1, right? I missed. Hang on. I still missed. Okay, but you got the idea. Almost fine. Oh, yeah. Okay, so that's this area in here. Let me change colors and make it purple. This area in here is another section, and then you've got
Orange.
I like orange too. Okay. Over here, you got all this section. So you're dividing the x-axis into strips. There's this strip, and the middle strip, and this strip. So you go from negative infinity, boom, to -1, -1 to +1, and then +1 the rest of the way. Because it keeps going over and up, over and up. And the range, what about the range? Just out of curiosity, jumping back. All real numbers. Okay. So we'll talk about the maximums and minimums, and then we'll be ready to talk about average rate of change and even and odd, and then we'll be ready to do work problems. Okay, any questions? Finish up the 1.5. Today is Thursday. Yeah, how many of y'all finished 1.5? All of y'all had already, right? Okay, so if you haven't, finish that up, and then we'll finish the notes, and we'll start working on the equations and stuff tomorrow. Questions? Hey, great job, guys. We'll see you later. Stop sharing and see how confused Candace is. Yeah?
I did just fix your picture with my questions over what we were going over in class, and is it all right if I email some questions over the...
Yeah, that'd be great.
I had some questions on the homework from yesterday.
Hang on just a minute. Okay, y'all finish with the chairs. Okay, say it again.
I do have some questions on the homework from yesterday, as I mentioned. Could I email those to you later?
Yeah, that'd be great too.
All right, thank you.
All right, and I emailed you a answer about the domains, right? Did you get that?
No, ma'am, I did not.
Okay, we can check your email. I think I'll go double check and make sure I emailed it, but yeah, about the domains. And also it had a link to another formula chart. Okay, well, I'll see you later then.
Thank
you.
Yes, ma'am.